In this session, we're going to talk about projectile motion. Now, what is a projectile motion? Or what is projectile motion? Projectile motion is just a type of motion where an object is thrown or is launched, into the air, and it moves under the influence of gravity, following a curved trajectory. Let's say this is our ground surface. Okay. Now there are different kinds of projectiles. Let's say this is our object that we are throwing. Okay. Then we throw it, and it is under the influence of gravity. Then it goes like that. Okay. This object is moving. This path the object has taken is called the trajectory. Okay. Now the total time that it has taken for it to pass through this path is called the time of flight. Now you're able to see that this projectile has also covered a particular distance, okay, from here to there. This will be called the range. This will be called the range. Okay. And this shape that we've seen, the bell shape, that one is just called the parabola. Okay, so for a projectile motion, it will be moving both in the y direction and in the x direction, unlike linear motion, which just moves in a straight line. Then it is going to be projected at a certain velocity, and it will make an angle. Okay, so it will make an angle. Let me say this is our vertical. Let's say this is our vertical direction. Okay, and let's say, let me represent this as our x, like that. Okay, let's say it's projected at like that. Okay, so what are we now going to have? We are saying this is the vertical, this is in the y direction, this is the x, this is in the horizontal direction. It is going to make this angle. This angle here, we call it the angle of projection. Okay, so at maximum, at this, like in this diagram, this will be occurring at 45 degrees, like that. Okay, that would be your angle at maximum range, like that. So those are some of the things that you need to understand. Then the other thing is this projectile will have it will have a height. Okay, now the height from here, it will have a height. Okay, that will be the maximum height. Let me call it h. Okay, now this is in the y direction, so you have to note that. Then there's something that I need to mention. In the y direction, or in the vertical direction, the vertical component of the, it changes due to gravity. So in the y direction, the velocity changes. Okay, velocity changes. But in the x direction, velocity will be constant. It will not be changing. Okay, your velocity will just be constant, like that. It will not be changing. So we have to also know that. That is very important for you to understand. Okay, now let's now talk about some of the key things that you need to understand. Okay, now how do you find your x component according to your SOHCAHTOA we say, you know, your Vx will just be equals to V cos theta. Theta in this case is the angle that you just projected your projectile. Then how are you going to find your Vy? Your Vy will just be V sine theta. Okay. Now, there's what is also called the range, like we've talked about. This will just be the distance in the y, okay? No, the range will be the distance in the x. Then, the distance in the y will be called our height, like we've just seen in that diagram, okay? Now, let's talk about in the vertical direction, because in the vertical direction, or in the y direction, that's where the change is visible in terms of velocity, okay? So, according to our, equations of motion, one of the prominent, equation is V is equals to U plus AT, okay? Now, at maximum height, here, your Vy is equals to 0, okay? That is worth mentioning, okay? So, in this case, our final velocity will be at 0 is equals to U, in this case, it will be Vy, the one that we're just starting with, not the final one, plus the acceleration. Now, this is the acceleration due to gravity. And we're saying it's vertical, it's going in this direction. So, it's going in the negative direction. So, your acceleration will be negative multiplied by the time. Okay, so now what are we going to have? We're going to have 0 is equals to we've got Vy minus gt, like that. So if we make Vy the subject of the formula, it will just be Vy is equals to g t, like that. Then if we're dividing by, let me say, if let's make t the subject of the formula. If we're making t the subject of the formula, it will be something like that, okay? So our t will be equals to Vy over g. Now you know that your Vy, it is this, okay? So our t therefore will just be equals to V sine theta over g. Okay, let me just write it on top there. So we're saying our t will be equals to V sine theta over g, like that. Now this is another important equation that you need to understand. So this is used to find when you're finding the time when it just reaches, like at its maximum, when it just reaches the maximum point. This will be the time of flight, okay? But now the time of flight that the projectile will take to reach at its maximum height, like for the whole time, for the whole period, you are going to multiply this expression by 2, because it's like you've gone and you reach here. So the first one you're just going to reach here, but for you to find also the other one, you have to multiply by 2. So that's what we're talking about. So for you to find your total flight, you're going to multiply by 2. Therefore, your t flight will just be 2 multiplied by your V sine theta over g. So this is another important equation that you need to understand, okay, if you're talking about your t flight. Okay, Let's continue talking about in the vertical direction. There's another equation of motion where I say v squared is equals to u squared plus 2as. Okay, the final velocity, like we've said, is equals to 0 in the y direction. We're talking about in the vertical direction, so it will be 0 squared is equals to the initial, in this case, is vy, right, and the squared plus 2. The acceleration, in this case, we're saying it's acceleration due to gravity, and it is in the negative direction in the vertical axis, so it will be negative g multiplied by your h or your s. Your s in this case is the distance. Now the distance is also going in this direction, that's the height. Okay, so it will be the height. The distance in this case is the height, so we'll put it like that. Now if we solve, we have 0 is just equals to our vy, we've just said is v sine theta, but now this is squared, okay, plus, or actually minus, because we have a minus there, so we have minus 2gh. Okay, if we make h the subject of the formula in this case, what are we going to have? If I take the negative 2gh to the other side, it will be 2gh is equals to v sine theta squared. Okay, first, for me to remain with my h, I'm going to divide by 2g. What am I going to have as my height? So our h in this case will just be equals to v sine theta squared over 2g. Now if we are going to distribute the 2 on top, what are we going to have? It will be v squared sine squared and theta. Please don't put the 2 on the angle. Okay, 2g like that. So this will be our simplified equation if you're finding the height of the projectile at that point. Okay, that is very important. Now with these equations that we have, there are 3 kinds of projectiles that you are supposed to understand. The previous that we have just from talking about, the one that we've talked about where it's just projected like that on the ground and it goes like that, this is the first that you can have. Now the second is, let's say let me say there's a building here, let's say somewhere is okay, it's like that. Let's say this is our ground like that. Okay, and let's put this one as our height. Let's say this is our height from here to there. Let's say this is our range from here to there like that. Okay, so this is our height. Okay, let's say this is just for illustration, let's say this is 20 meters. Okay, then the range, let's say the range from here to here, this we could say this is the range. Okay, so let's say the range, in this case the range, let's say it's okay, let's just call it the range. Okay, then we've got an object here. Now this object just comes like that and it moves and it goes like that. Okay, so because it is just moving in the x direction, so this will be our vx. Okay, vx like that. Let's say this is 10 meters per second. So let's call this one point A and let's call this one point B. Okay, now this projectile can also make the shortest distance. You know that instead of it moving the way it has moved, you can also make a shortcut to here, okay, going to that point. Okay, so let's call this point, this will be called the displacement. So the displacement in this case will just be the shortest distance this projectile will take. Okay, so now that you've got this kind of a projectile, what are the essential things that you need to understand? On this projectile, you have to know how to find the height if they have not given you. You also have to know how to find the time and also the range, okay, and the displacement. Now the displacement in this case, you're able to see that you're just going to use the Pythagoras theorem, okay, for you to find the because this is a right angle triangle like that, okay. So now how do you find the time? You're going to use, you're going to take advantage of the equation that we have, where you say if you're finding h, s, we say s, right? But in terms of projectile, since it's in the y, you're going to say h is equals to ut plus half at or gt squared, okay. So what are you going to have? Your height in this case we're saying is 20 is equals to your initial velocity in the y direction. There's nothing in the y direction like we've seen, so just be 0, okay, plus half the acceleration due to gravity. You are saying there's nothing in the y, but this projectile is going downward, okay. Because it's going downward, it will just be positive, so 9.8. This is multiplying by a time. Let's say the time that's what we're trying to find. So let's call this one t squared, okay. So what are we going to have? We're going to have 20 is equals to half of 9.8, that is just 4.9 t squared, okay. For you to find your t, you're going to divide by 4.9 on both sides, okay, and you square root that. So the t that I'm finding, it will be 2.02 seconds, okay, like that. So that would be our time. Then how do you find the range? Okay, the range is the distance, okay, the distance in the x direction. And like we earlier said, in the x direction, your velocity doesn't change, okay. Remember we said speed is equals to distance over time. For you to find your distance, you said distance is just equals to speed times time. But now in this case, we're just talking about the velocity. So we're talking about velocity. So in this case, the distance in this case will be the range, okay. So the range in this case will just be range is equals to, it will be equals to the velocity in this case. But now this is in the, you're able to see that this is in the x direction. So this is Vx multiplied by the time that we've just found, which is 2.02, like that. So this will be the time. So allow me to write it there. So the range will be the velocity in this case, or the Vx in this case, we're saying it was moving at 10 meters per second. So it will just be 10 multiplied by your 2.02. So the range in this case will just be 20.02 because it's distance, so it will be meters. So that's how we find these are some of the key things that you need to understand on this kind of a projectile. Okay, let's talk about another kind of projectile that you can have. Let's say you have this kind of a projectile. Okay, that is our height from there to there. there's a range from there to there. Okay, so let's say this we're saying this is our height. Okay, let's say this is 15 meters. Then what other thing can we put? Okay, so this is our projectile here. Now this projectile, it moves instead of going straight like the one that we had, which the one that was going like this. Now let's say it has been projected up, and it goes like that. Okay, now you are able to see that this is a combination of the one that we had in the first example and the previous one. Okay, so because it is a combination, you have to be very very careful on how you solve this one. So let's say it's projected at a velocity of the same analogy. Let's say it's 10 meters per second. Okay, let's say it's projected at an angle of 60 degrees like that. So this projectile will have two heights, this one that we've indicated and the height that it has made when it was going up. So let's also indicate this height. Okay, so the height from there to there, let's also call it h. Okay, and let's say this is point A, this is point B where it has reached. Okay, and this is our range. Okay, let's say this is our range here. So what now are you supposed to know on this one? Because we just talked about the first one and the second kind of projectile. So for this one, you have to also know how to find the time flight for this kind of a projectile motion, or for this kind of a projectile. Okay, so let's first find the height. Okay, first let's find this height. Okay, so we are going to say 2 as is equals to v squared minus u squared. Okay, so in this case it will be 2g h is equals to v squared minus u. I've replaced g and h with a and s. I've replaced a and s with g and h because we're talking about extraction due to gravity and it's in the y direction, so it's the height. Okay, so it will be 2 multiplied by the acceleration due to gravity, because in this case this one was going up. Okay, and we're trying to find this height. Okay, because it was going up, we find that it will be negative, right? So it will be negative 9.8. okay, this is multiplying by h. Okay, is equals to our v squared. Our v squared, that is the final velocity, and you know that our final velocity at this point, that is be our final velocity vy, is equals to 0. Okay, so it will be 0 squared minus u squared. U squared, we said it was projected at 10 meters, so it will just be 10 meters per second squared. Okay, so when we do the math, what are you going to have? Okay, our v squared, our u squared. Okay, this is our v squared, so no, not really like 10 squared. Okay, like that. Actually it will be 0 minus u squared. Okay, so in this case 2 multiplied by that by negative 9.8, we have negative 19.6 h is equals to, now we've remained with u squared. U squared, that is the initial velocity, and vy, we know that vy is just found by v sine theta. Okay, so in this case our v is 10, we've said it's 10, but it's sine, it was projected at an angle. Okay, sine theta. okay, or sine 60 actually, because it was projected at 60 degrees. Now this is squared, okay. So when I calculate, I'm going to find negative 19.6 h is equals to this. I'm finding negative 75, like that. Okay, yeah, negative 75. If I divide by 19 on both sides, I'm getting our h as 3.827 meters. Okay, so that would be this height there. Okay, so to find the total height, you just add this plus that. Okay, now how do you find the time of flight? Let's say this the time of flight, or the t flight. Now when you're finding the t flight for this one, you can either choose to move from A to the maximum here, and you add that plus you add this plus that, like that. Or you can use the quadratic formula like that. Okay, so let's just do the other part. So what I'm going to do, let's just arrange our numbers. Let's say this is A, this is B where it's maximum, and this is C. So we'll move from A to B, and from B to C, or from C to, yeah, from like that. So what are we going to do? So let me use the okay, can I write from here? Okay, let me just use the next page. So to find T1, what are we going to have? We're going to say our V is equals to U plus GT. Okay, this will be equals to, we know that our final velocity is 0, right? Our initial velocity, we said, is just Vy, which is 10 sine theta. Our theta is 60, right? Plus our G. Now our G in this case, it was moving in the vertical direction, so it would be negative, right? So it would be negative G T. Okay, so 10 sine 60, we just have to find that minus 9 point. So let's take this one to the other side. What are we going to have? We're going to have GT, or in this case GT, that is our acceleration due to gravity, just 9.8. So let me say 9.8 multiplied by T is equals to 10 sine theta sine 60, which is just 8.66. Okay, now when you divide by 9.8 on both sides, our T1, let me call it T1, will just be equals to 0.883699, like that, and you'll be continuing like that. Okay, so this is our first one. So it has moved from A where it was, it has gone to C, then now it is going to B. Okay, so this is our surface. It went like that, and now it's going like that. So just found at from A to C. Now how about from C to B? So what are you going to do? So now from C to B, you're able to see that this is like the total height. So we're going to take advantage of the total height. So what are you going to have? So we're going to say height in this case will be equals to UT plus half AT or GT squared. Okay, so now your height, we've already found that it will just be 15 plus the one that we got, it was 3.8. okay, is equals to our initial velocity at this point. Okay, what would be our initial velocity at that point? Okay, so what will be our initial velocity at this point? We know that at this point this will be our maximum point. Okay, and at that point, you know, it is 0. Okay, so this is 0 plus half g. Our g is 9.8. Our time is the one that we're trying to calculate. Okay, this is t2. Okay, when we add these two, 15 plus 3.8, that's just about 18.8 to like that. Okay, is equals to, okay, the half of 9.8, that is 4.9 t squared. Okay, when we solve for t2, I'm just finding something like 1.960, something like that. Okay, so now when we have these ones, what are you going to do? You have to add them together. So you're going to add them. You're going to add this plus that. So your t in this case will just be 2.84386, like that. Okay, these are seconds, like that. Okay, so that is very important for us to mention. Then how are you going to find the range? Okay, before I go to the range, this is method 1. Now method 2, the other method that would have used is, we're going to this is our height, right? In this case we're going to set it to be negative. Okay, then we're going to say it to be negative h is equals to u plus half gt squared. Okay, so now you know that because it's moving in the opposite direction, your g will be negative and your height will be negative. But now just make sure that when you solve, it will give you a quadratic expression. Okay, and when it gives you a quadratic expression, solve using the quadratic formula. But you know that quadratic formulas always give you two answers, right? It will give you t is equals to something and t is equals to something. Now only get the positive answer, because you know time is best, you know, expressed in positive form. So that's how we're going to do. Okay, then now how do we find, if they ask you to find the range? Now we have the range there. How are we going to find the range? Okay, the range is just in the horizontal direction, so the range will just be equals to vxt. Okay, your vx in this case will be 10 cos 60 multiplied by your time, the time that we just found, which was 2.8, and it was going like that. Okay, so when I do this, I'm getting something like 14.2 meters. Okay, so this will be the range, okay, for this projectile, you know, to reach the surface. Then they can also ask you to find the velocity. Okay, the velocity with which it will hit the ground. Allow me to wrap this part. Now how do you find the velocity with which this projectile or this stone is going to hit the ground? Okay, so you know that your Vx is just equals to V cos theta. Okay, so we're going to find both in the x and in the y direction. Okay, so because when it hits this ground, there will be two things, because it is going in this direction, so you need the y direction or the y component, and it is also, because it is hitting the ground which is linear, you also need to find you know, the velocity in that direction, which will be the x component. Okay, so the x component in this case, we're going to do what? It will be 10 cos cos 60, in this case the theta was 60. So what are we going to have? It will be 5 meters per second, like that. Okay, now for us to find the actual velocity, we're going to we also need to find Vy. Okay, so Vy in this case will just be, in the y direction you have u plus gt squared. Okay, so in this case our u in the y direction, you saw that this is just a 0 in the y direction. Okay, the maximum, at the maximum it will be 0 plus our g in this case is 9.8 multiplied by our time. Our time was found this at this point, because this is the final velocity, okay, in the y direction. Your Vy at that point, in terms of your initial in this case, because that's where I'm starting from, again to be 0. But now the time that we're talking about, it is from here now going in that direction. Okay, so you're going to get 9, the one that we had found at first, our t1, okay, or our t2 actually. Our t2, that's the one that had the height, so it will be 9.6, like that. And you're, when you solve that, you're going to get something like 9.2. Okay, now to find now the final velocity, what you're going to do is you're going to say v is equals to, you're going to square both. You're going to find the square root of vx squared, which is, we just found 5, plus your vy squared, which is, we just found like 9.2. Okay, so when you solve these ones, when they're squared like that, you're going to find the square root of 393.9. now the square root of that, this is just 19.8. okay, 19.8. so this would be our velocity as it reaches the ground. Then the other thing that it can ask you to also find is the direction with which it is going to hit the ground, the angle, because as it hits the ground, it will make a certain angle, right? So now how are we going to find the angle? So the angle, we're going to say theta will be equals to the tan inverse of the Vy divided by the Vx. Okay, so how are you going to do that? Allow me to rub this part. How are you going to do that? So tan inverse, so to be tan inverse of our Vy, we just found that it was 19.2. okay, our Vx, we found that it was 5. okay, so we find the tan inverse of that. On my end, I'm getting 75.4 degrees. okay, so that would be the angle at which it will, as it hits the ground, that would be the direction it will make. Okay, so these are some of the things that you need to understand on projectile motion. Once you get all these 3 components on all the 3 kinds of projectiles that you're going to have, then you're good to go. Thank you. See you in the next session.